Hi, welcome to Experiment 3 in the Robotics Lab, and today we are going to control a servo motor using an Arduino microcontroller. So first, the objective of this experiment is to control the angular displacement of the servo motor. For the equipment and materials, we need one personal computer, one Arduino microcontroller, one USB cable, one power supply, one breadboard, one servo motor, and 3 connecting wires. First in this activity, we will be going to control the movement of servo motors. The movement of the servo motor is controlled through a program implemented in Arduino. The servo motors are connected to the microcontroller. The microcontroller will send pulses to the servo motor with different width that correspond to the angular rotational displacement of the servo motor. So the angular data is needed to be fed to the microcontroller to instruct it to rotate in that angle. First, for the procedure, we will connect the computer and Arduino microcontroller using USB serial cable. Then second, connect the black cable to ground, red cable to 5V, and the yellow connecting wire to pin 9 of the microcontroller respectively. So the color of the connecting wires from the servo motor may vary based on the model of the servo motor. For the program, we will create a program for the microcontroller that will control the angular displacement of the servo motor by sending pulses with different width that correspond to the angle of the servo motor. So we will be creating two codes to control the servo motor. First is manual and second is automatic. In manual, we will be using serial monitor to input values and instruct the servo motor to rotate based on the input in the serial monitor. And for the automatic, the servo motor will automatically rotate based on the input values created in the program. For the circuit design, let's go to Fritzing. So here we have Arduino Uno Rev 3 and a servo motor. First, the PWM output from the Arduino will be coming from here, the pin 9, and connected to the yellow pin as input in the servo motor. Then for the 5V power supply from the Arduino, connected here on the red pin of the servo motor, and for the ground on the black pin of the servo motor. Now let's see the schematic. So as we can see here, D9 PWM is connected here on the second pin of the servo as pulse. Then for the positive input of the servo motor, it is connected on the 5V output of the Arduino. And for the negative input for the servo, it is connected to the ground of the Arduino. Now let's create the code. So for the first code, we have here include servo.h. So we included the servo library. Then we declared an integer variable, angle equals 0. So we assigned the name of the servo as my servo. Then for the void setup, serial.begin enclosed 9600. So that will be the baud rate for the serial monitor. Then my servo.attach enclosed parenthesis 9. So that assigns pin 9 as output to control the servo motor. Then for the void loop, we have here angle equals serial.parse int. So whatever value we input in the serial monitor will be the value of the angle. And if angle is greater than 0, then my servo.write enclose parenthesis angle. So whatever the value of the angle will be the reference for the servo position. Then serial.println enclose parenthesis angle. So that will just display our input in the serial monitor. And delay 15 ms, so that is the speed of the rotation of the motor. Then let's go to tools, serial monitor, is input 180, 90, 1, as you can see, 1, 5, 10, 20, 30, 40, 50, 70, 180, 120, 90. So this is the 90 degrees of the servo motor. And the 180 is 180. Then let's go to 1. There. So we cannot enter a value of 0 since in our if statement, the servo motor will only rotate at an angle value greater than 0. Now let's try 3. 90, 85, 95, there. So for the second code, we have here hashtag include servo.h. So we included the servo library and servo space servo underscore test. So we name our servo as servo underscore test. Then we declared an integer value named angle, which is equal to 0. Then for the void setup, servo underscore test that attach enclose parenthesis 9. So we assigned pin 9 of the Arduino as output to control the servo motor. And for the void loop, we have here two for loops. So for the first for loop, so here we have an initial angle value of 0. Then if angle is less than 180, Then the angle value will increment or increase by 1. So this code will loop until the angle value is greater than 180. So we have here servo underscore test, that's right. We also have delay 15 ms, so that is the speed of the incrementation or the speed of the loop code. So after the looping and incrementation, if angle is now equal to 180, then delay 1000 ms, so that is 1 second. Then we will proceed on the next loop. So on the second for loop, now that the angle value is equal to 180, if angle is greater than or equal to 1, then angle minus equal to 5, which means that the angle value will decrease by 5 per loop. So here servo underscore test, that right angle, then delay 5 ms, so that is the speed in which the angle value decreases by 5. Now when the angle value is now equal to 0, then delay 1000 ms again, and the cycle repeats over and over again. Now let's compile and upload. And as you can see, from 180 to 0, the servo motor rotates at a faster rate than when the servo motor is processing from 0 to 180. You can see here, slow, slow, then fast, slow, fast. So we can say that we can change the pace of the rotation based on the delay value in the code. There.